To calculate biotic potential for your duckweed, we're going to use the formula N subscript T equals N subscript 0 times E to the RT, which seems like a really weird formula, but when you look at the definition of each of those terms, it makes it a lot easier. So if we started with our duckweeds at day 0 and added 10 plants to the cups, and after 14 days, we've counted 19 duckweed plants, then we can use that data there in order to determine the biotic potential. So starting with T is how long you ran the experiment in days. So we went for 14 days, so T is equal to 14. NT is the number of individuals at time T. So after 14 days, how many individuals did you have? After 14 days, you had 19 duckweeds. So N to the T equals 19. The N to the 0 is the number of individuals at time 0. So day 0, we started with the 10 duckweed plants. E is the natural logarithm. So that's where our calculator comes in. And then finally, R is the value that we are trying to find, the biotic potential. So if we plug these numbers into this formula, NT is equal to 19. So 19 equals N0, which is 10, times E to the R, which is what we're trying to find, and T, which is 14. Okay, to solve that then, we want to get R by itself, so divide both sides by 10, and we have a phone that went to sleep. All right, so we have 119 divided by 10. Probably do this one in your head. So 1.9 divided, and then this side divided by 10 is canceling out the 10. So we're left with E to the R to the 14th. So 1.9, if we try to get R by itself, we divide by E. So divide both sides by E. And this seems strange. On this side, E cancels out, so that's fine. But 1.9 divided by E is where our calculator comes in. So if you plug in, you have 1.9 and you push the IN button, the inverse button, that gives you the value of 1.9 divided by E, 0.642 is equal to R to the 14th. So divide both sides by 14 to get R by itself. So if you have 0.642 divided by 14, R is equal to 0.046. And there is your biotic potential for your duckweeds.